All right, welcome everybody. Tonight is the Tuesday, May 31st in Dallas. This is Dallas Personal Robotics Group Robot Builders Night Virtual. And we have a kind of a slower start this week, summertime hours and crowd, but we still have at least 2 or 3 people with topics to discuss. So we'll just go around the table and talk robot things. And I think, David, you might be first, and then if Doug's ready, and then Michael and whoever else. David, take it away.
Okay. Let me share my screen here. Well, let me talk a little, and then I'll share my screen. I just shot some new video for a talk that I'm going to do coming up down the road. And I know I talked to you all about how poor quality the videos are that we share on this because of the choppiness of it. And I would gladly sacrifice resolution of the image for a smooth frame rate, which I think is much more important to showing what the robot does. And so I got and downloaded OBS, and I told Carl I was going to call him last week and he'd go through it with me, but I didn't. So what you're going to see here is the old choppy ones that I'm complaining about. And it'd be interesting to get some feedback for that very purpose. So, okay, let's see. Am I sharing?
Yes. Indeed.
Okay.
Yep.
Okay, what I have here is was mentioned earlier about having what John was saying about having test suite built into your robot, and I have actually a whole bunch of test suites built in, and one of them is to test out the navigation and the odometry. There's a suite of built-in geometrical patterns defined by waypoints, and they're all scaled to 1. So I can then have a multiplier to make them any size I want. So for example, if I want to go in a straight line for a certain number of feet, there's one that only has 1 waypoint in it, and I can scale that by whatever I want. And likewise, I can drive around a square. I can do all of these clockwise or counterclockwise, so that's how I do the Borenstein UMB mark, as well as the Foursquare contest. I can drive triangle, a square, a figure 8, straight line, and a couple other things I can't remember. But those are basically always there in the robot. And so, for example, if you change the wheels or you take apart the chassis and put it back together, you want to check the calibration and so forth, that's quick and easy to do without having to have some kind of special calibration routine. So this first video, can you all see my mouse?
Yes.
Yes.
Okay, what I've got here is 3 waypoints. I've got some electrical tape laid out on the floor here. This is the foyer of the building where I work, which is a nice big open space. This is at night when nobody's there. And I have a waypoint over here and a waypoint over here and this one back here. So basically it's a isosceles right triangle with the robot set here bifurcating the right triangle. And this is kind of like with the standard odometry I've showed you guys many times. Can you hear the audio?
Yeah. Yeah.
Okay, so you'll see the robot decelerate, come to a stop, a red light comes on, and it beeps when it gets to the waypoint. Could you hear the beep?
Indeed.
I couldn't hear it.
Okay, I can say beep out loud. So watch the red LED come on there and
Beep, beep.
beep. There you go. Okay, and in this case, you can think of it as having like 3 states. There's a navigate steering state, there's a slow down and stop state, and there's a rotate in place state. And so, okay, so that's kind of like the bare bones of what it does. Okay, so this is the same thing, and the difference is that I've turned off the flag that tells it to stop when it gets to the waypoints. So it just drives directly through the waypoint. And as it crosses the waypoint, as the center of the robot crosses the waypoint, it fetches the next waypoint from the list. So it begins steering toward that waypoint. So in this case, there's not 3 states, there's just 1 state, the navigation, which is running the whole time. And I've also got the IR avoidance sensors turned on for this run. And so one thing that's obvious is that it's not going to drive basically straight along the line, the lines of a triangle anymore. It's going to overshoot that point and come back down, and it's going to do sort of a more efficient curved path without stopping. And you can still maybe hear the beep.
Beep,
We're hearing the low frequencies.
Yeah, that's the fans in that room. So it arrived at the first waypoint. It begins steering to the second one. And again, if you can't hear the beep, if you watch the red LED, it comes off just before the waypoint and goes off there when it reaches the waypoint. And this is going to continue, rather than just do that pattern once, it's going to do it continuously. So just there, it fetches the new waypoint.
It's a dangerous place to robot. Boxes falling from the sky.
Human, exterminate.
They're really trying to confuse it.
And this is all odometry, yeah?
Yes, it's wheel odometry and a Z-axis rate gyro.
And the rate gyro, okay.
Funny, I can hear those boxes hit the floor just fine, but can't hear that beep.
Beep.
It sounded remarkably human-like, that beep.
Beep.
See that?
Okay, that's all there is.
Very nice. Nice demo.
Thank you.
New video, gold star, yeah?
Yes, yeah, the video's just 2 days old.
Excellent. All right, there, right on the forehead. Glasses, that works. Very cool.
Well, I was hoping to demonstrate, you guys know all this because I've talked about it for years ad nauseum, but I've been talking to some other robot builders in the not recently who are convinced that odometry is useless because they themselves have never made it work. So I wanted to make a simple demo. I don't run any sonar on that demo. It's all IR because sonar has a much better idea of the space you're in, and it's more intelligent and therefore more confusing to figure out what it's doing. So I just wanted it to use the close-in IR so it was real obvious what was going on when it was avoiding objects and recalculating locations. And, some of the people I talk to, and especially university people, as you know, are very far down the Ross rabbit hole. And what I just demonstrated, I think, is what they want to do. but they've made it so hard as to be almost undoable. Even a smart guy like Chris finally threw up his hands and gave up on it. And anyway, I wanted to demonstrate to them that it was doable and in a much simpler, what's the right word, methodology.
Did they buy into it?
Haven't done it yet.
Oh yeah. Oh, okay.
You guys were the guinea pigs.
Excellent.
But as I say, you all know too much.
We've seen that trick before. We need new tricks.
Yeah, exactly. Like this one, right?
Although the box drops are pretty good. Where'd your thumb go? Okay. Oh, cool. All right. Well, very good. So I think you're primed, and we'll look for you to show them the benefits of odometry and see what they say.
Well, I'm sorry I only took up 5 minutes.
That's
Quite
all right.
rare for me.
We'll sure you'll make up for it sooner or later. I think, Mr. Doug, you're next. Do you have the thing you wanted to share?
Yeah, I want to show just something that this is more for people looking at Robo Columbus, okay? I'm going to share screen here in a minute. Okay. All right. Now I can't see what's going on, so it's going to get a little weird here. All right. This is GitHub by Mark Dana. It's called Real-Time Cone Detection. And what I was really looking for, he has essentially 260, I think, cones in all of this, and he's released the data set. And so you have the pictures, so you could add to it if you wanted to. Let me go back to my other. He also has the YOLO 3 annotation of these. So this describes where the cones are. You have to have a picture and you have to have a box on a picture. That's what that text does there. And he also talks about his journey. And so here's what you would see if you were watching the video of those particular pictures. And then he gives down here, if you don't change the data set, if you just use the weights, which he also has listed, then you can create the model, your model yourself with not too much there by just going to YOLO 3. So anyway, and he has some utilities available, which can be useful. And he explains a little bit about it. But anyway, so this is I'm going to grab the link and put it in the chat. This is a really good leg up on putting those OAK-D lights to work on Robo Columbus. So that's what I was really looking at.
So
okay, so that's all I had to show, but I wanted everybody to see that in case they were interested, to give them as long a lead time as they would need to get into it. So I'll put that in the chat.
So Doug, is this it looks like it says network based on YOLO v3. So is this ready to run in something, or?
Well, that's what I'm saying is he releases the weights. So, and you could probably, I'd have to look a little more deeper into what is configuration, but in theory, you've got the weights, you don't even need the images. All you need to do is plug it into the model, okay? But I would probably add a few more pictures to it that were to my local cone, just because I got to do something. And but trying his first would be the way to go. You just take it, put the weights in, see if you can replicate his results.
Well, I'm lost at a more basic level because I don't know what YOLO is.
It's
You only look once.
you only look once, yeah. And it's actually up to YOLO 5 now. But YOLO 3 was a
Too
big
helpful.
breakthrough. And
It's a-
so,
It's a software package. Carl.
yeah, it's a software package.
Neural net software is what it is. And
Okay.
it's,
Yeah.
All right.
I've been actually been meaning to get a book on it and start, in particular, Yellow on using Python. If I could find a good book on that, I'd like to start learning that.
Boy, if you could 3D print that, that'd just have everything.
3D print what?
Well, you have your neural net, your 3D printer, and Python all in one handy package.
Oh, well, yeah. Just give me another project and I'll try to 3D print it.
Doug, how you say they give you the weights? How much data is that?
He used, I'd have to go back and look at it, but I want to say there was 266 images, I think he said in it. If we go to that website, if you click on that.
I'm asking if you don't use the images, you just use his weights. How much data is that?
Oh, you mean how big is the weights? I'm not sure how big the file is. I'd have to look at it. It'd be there under the weight files.
8 bytes or
No,
100
it's bigger
kilobytes?
than that. No, let me.
10 megabytes?
It's bigger than that. Give me a second.
Bigger
Oh, you're gonna make me go look again.
And while he's looking, David, can you summarize for me how weights are applicable? It's not like you're applying a weight to an image to say, I think this is how much I think this is the object you're looking for. It's something completely different, right?
This is a neural net, right? So you show it a bunch of pictures and you're showing it 2D arrays of pixels. And it's going to make some decisions. You're telling it these are all related. These are all the same objects. But we have no idea how it's actually making that decision. It comes up with a bunch of weights that are indecipherable to human beings. That's actually one of the reasons I'm kind of skeptical of that whole neural net approach. If you take a human being, all you got to do is show them one traffic cone. They'll recognize every traffic cone, different angles, different lighting. They'll recognize if it's got tape marks on it, if it's a different color, you know. So clearly the way we're training up these neural nets is not the same way our brains work. And as I say, we don't really know what they're doing. They're going to come up with all these weights, and when you give them the weights and give them a picture, they're going to say whether or not those weights to them suggest that picture is the object you're looking for.
So when you say you're skeptical,
Well, I think no. I want to say that you're
really. Go ahead. I'm sorry, Doug.
what I'm saying is, if you took an infant and you showed him a traffic cone, do you think he'd know what it was?
Why do we have to take an infant? Why don't we take a 5-year-old or a 7-year-old?
Well, that's what you start off. What I'm saying is, basically, if you look at the way a neural network is,
I do not believe an infant needs to
you know,
see.
you start to have to learn to train the network. The neural nets, you know, I suspect that they are very close to the way we start off. It's just that we have so much data and our weights are so adjusted that it's hard for us to even conceive of the beginning.
Well,
Neural
I think what I'm
nets are based around the idea that you're going to have a data structure which resembles a bunch of brain neurons. But those are actually just done with real simple gates, where brain neurons are much more like a very complicated microprocessor at each node. So the neural net doesn't even begin to model what's going on in the brain. I would be stunningly surprised if the way we learn has anything to do with
so I think hold on here. I think what David is saying is he's not skeptical that it's not a useful tool.
Exactly.
He's just saying he doesn't buy all of the argument that this is really what is very close to what the brain does. Very close to what a human brain does.
Just to use the yellow 3 weights, they're 242K.
242K.
Right.
So
Thank you.
What I'm trying to get my brain around is, I mean, you go find YOLO libraries and then apply these model files and weights, or?
Yeah, I'd have to see. I just found when I went to the weight script, I found that he's actually has the weights somewhere else and you have to download them. So I don't know if I'd have to go take a look and see if the neural network configuration is standard or whether there's something unique about it. But right now I'm assuming that it's standard. Okay. Because, if you have, let's say you have a simple neural network, you have 3 input pins and 2 outputs and 1 hidden layer that's got, say, 5. It's going to be 3 times 5 times whatever the last one was, 2. That's how many weights you got to have. And if you have one that's got 2 or 3, 4 or 5 hidden layers in it, and they're all like 150 to 200 neurons each, that's going to be a monster amount of weights that you have to calculate. And that's what the training does. It just keeps running it through, training all of those things over and over and over again. So, the state of the art, big ones, now they have millions and billions of weights. But we're not talking, that's stuff like Google does, not what we do. And maybe Harold probably does that stuff, but not us on our little robots.
Well, I have a slightly related project that I'm working on. I'm still working on that license plate reader. I'm trying to see if I can write code that uses OpenCV and Tesseract. If I can beat that, I don't want to say off the shelf, that open source OpenALPR software that I was using for the camera, and I'm kind of hit a wall because there's lots of issues that I'm running into now. I've actually got to the point where OpenCV can actually do better percentage-wise looking at an image and figuring out if there's a rectangular plate there. I think I see a license plate. It does better than OpenALPR, but what I'm kind of stuck on is that the Tesseract, the Pi Tesseract module that you can get, it's not very good at decoding the text. For one thing, the training data that you get with Tesseract, unlike OpenALPR, which is only looking for like uppercase characters and digits, the training data that I've got with the Pi Tesseract is uppercase, lowercase, digits, symbols, everything. And so I'm getting all this noise, when it tries to decode the characters on the license plate. And I was wondering, and I'd asked in a couple of forums, is there any way that I can get training data for Tesseract with just uppercase characters and, not getting all this noise, coming through? And one of the things I thought of is, well, maybe, I don't know what format the training data is in. Maybe I can go in there and sort of trim out all the garbage. I don't know. But that's kind of where I am now.
John, I saw that nobody had responded to your Substack post. I checked it a couple of times, and nobody seemed to respond to the DPRG list. But fortuitously, the guys who prowl the parking lots at SMU with their license plate reader, handing out tickets, just happened to be in the parking lot. So I stopped them and talked to them. And I asked about how the system worked. And this was the disappointing part. When the system can't read a license plate, then that's the same as if the license plate is not in its database. That is to say, it doesn't automatically give a ticket. What it does is it tells the human operator, here's one you have to check out by hand. So that does, in other words, where their algorithm fails, they've got a human sitting there and they say, we can't figure this one out. And he has to go look at the license plate.
They're cheating. That's cheating.
So I was hoping, that's kind of what I thought.
That video that I put in the chat last week, where it was the guy showing all the mistakes that Pat
Yeah, John,
Pat had found. if you watch
sorry,
that
what?
one, he talks about, he has two categories. He has license plates and blurred license plates. Now, I'm just saying, I'm just pointing out this is how somebody else approached the problem. I don't know if it's any good or not, but so there might be something there, like if you get to a certain point, if there's movement in the frame, I mean, or if there's something about the picture that gets it classified as a blurred license plate, you don't try to read it. Okay, you only try to read one where it says this is a license plate. I mean, that might help.
Well, like I said, I think I've actually beat OpenALPR in just based on perimeters, on finding a contour that's approximately a parallelogram and then dewarping it to a rectangle, and say, yes, I think that's a license plate. It does better than OpenALPR does at that, I believe. But the next step is reading the text, and it doesn't. And I'm running into all sorts of problems with the text. One being, and I don't know if David saw my post on Stack Overflow. When I extract contour, the contour is always slightly rotated, which when I dewarp it, actually has the text rotated. And then the tesseract is if you rotate the text more than about 5 degrees, it starts throwing tesseract off at being able to identify the text. So what I was looking for as a kind of a workaround is to find some technique where I could detect the rotation and rotate the text before I try to decode it. Unfortunately, Tesseract 4.0, well, I'm sorry. There's a Tesseract can actually, there's a function that they provide that you can get, or mode for Tesseract, that you can tell it, give me the metadata about this text, about this image and the text that might be in it. It can detect character rotation, but only if it's got at least 133 characters. So, so detecting rotation in something as low as 6 characters is just apparently beyond Tesseract's capability currently. So I can't even get that part fine-tuned to get a better result. So if you give me a few minutes, I just fired up my Raspberry Pi that I'm running this on. Y'all go into another topic and I'll come back to this and show you what I'm talking about.
Yeah, okay.
Cool.
Sounds like when you get all this working that it would be a challenge for those members of the club to try to drive by John's house without our license plates being read.
We can have it just kind of like, wiggle all over the place instead of being in one place,
Or the
I want to
James
see that
Bond,
coffee.
digits
Yeah.
roll,
Yeah.
Just tilt the license plate like 40 degrees.
Yes, exactly.
never get read, right?
I probably just tip it by 5 degrees would be enough to blow up the algorithm.
Hey, John, have you ever encountered
Or you could have like have a gloss
polarizers?
black, you could have a gloss black and a matte black, and that kind of stuff on the thing. So a human could read it, right? By seeing the glossy versus the matte thing and see how that would do.
I'm sorry, was that a question to me?
No. What I'm saying is one of the things you could do as well to make it hard to read was have black and have a glossy black and a flat black, where a human being could probably discern that at the right angles or something. And I don't know if a computer could do that as well.
One of the things I figured out to do recently is I found some code, and it only takes a very few lines of code to do auto brightness and contrast on an image in Python or in OpenCV. So let's see if I got.
John, have you ever encountered it's like I'm guessing a polarizer that at a certain viewing angle, probably the angle that the cameras on the tollway look at license plates, it obscures the plate, but at like a shallower angle, you can see through it? or you can actually see the characters of the plate?
Well, in most cases, in the images I'm not having too much difficulty getting a good image in most cases. But some are better than others. I'm still working on getting my demo running here. Why is it not working?
Doug, had you shown what you wanted to show then earlier? Doug P, you're muted.
Oh, I see what I'm doing wrong.
I'm sorry. Go ahead again.
All right. Yeah.
Are you talking to me?
Yeah, you were showing.
I showed what I wanted to show.
Okay.
I just wanted to make people aware of that data set, so that if you're making a cone data set, here's one that somebody's already put a gazillion images and already put where the cone is in the picture, which is the hard part.
Cut and paste library code. Okay.
Yeah.
I don't know if you guys watched the video that Doug, or the link Doug posted to the list. I guess it's been 2 weeks ago, Doug, for the fellow who went through all of the.
It was Pat. Pat actually posted it.
I
just saying, this really was worth looking at.
Yeah, I thought it was very good.
Yeah. Yeah.
Well, if we're still waiting, I've got another totally unrelated robot thing.
Oh, here we go. I've got it up now.
Okay, so we got John, we have Michael in line, and we got a totally unrelated robot thing. Okay.
I think Jack's going to show us something too.
And then Jack's on the spot. So we got a good.
Jack, are you going to make us a cup of coffee, Jack?
It's getting there, but it's having some problems.
Can you see that? Am I sharing?
Mm-hmm.
Yeah.
Yeah.
All right, so I've got this set up where you can see various stages where it's going through each image. That's the edge detection. All right, and then that's where it's trying to find a contour. Now it failed on this particular image, so I'm just going to step through it and move on to the next one. I think this one's a good one. Yeah, that one's got a nice clean contour that it found from edge detection. All right, now here's the part that's going to be kind of hard to see, and you might not be able to see it on your screen. You see with the green boundary is where it says, oh, I found a contour that's approximately a parallelogram in this area that looks like a license plate. So I'm going to call that a plate. But if you look real close, the green lines are not exactly following the edges of the plate. It's kind of rotated. Can you tell that?
No, a little small.
Yeah, it's probably too small, and I can't zoom in. But you'll see here in a minute. Well, there's
John, it looks like the green lines are normal to the.
I can see it.
Can you see that it's slightly rotated?
Well, it doesn't look
Yes.
like it's rotated. It looks like that the green lines are square with the frame of the picture. And it's the license plate that's not square with the frame of the picture.
Right.
No, that's not what's going on. What's going on is it's taking that contour, which is represented by an array of many points, and performs a approximation. It keeps reducing the number of points in the contour until it gets down to 4 points. All right, and then the code says, are opposite sides roughly equal in length? And is it, in other words, is this a parallelogram? So it goes, yeah, I think this is a plate, and then it will de-warp it if it thinks it's a plate. The problem is it's not exactly drawing the contour. The points that it finally picks, every one of those corners is a point on the contour from the edge detection, but it's not hitting the points right at the corners, where you see those corners in the white contour. It's actually off by a point or two. And so that's rotating the image. So, if I space through it, this is okay. This is the plate found page. Okay, and there it is. You see how the text is rotated?
Yeah.
Yes.
Yes.
Clockwise.
Right. So when
It's
he dewarps
rotated
it,
clockwise.
Yeah.
yeah, and a lot of my images are coming out that way. Plates that it finds, it's actually rotating the text, and so when it goes to decode it, that comes out as I mean, the plate's PVM 3165 and it got PYN I16S. And you can see I've got a raw value and a translated value. What I did was I also created a map of, I watched to see how it gets certain characters wrong that are not in my data set. And this is not actually a good example because this has all uppercase and digits except for that dash. But I did, you know, in my map, I do say a dash correlates to nothing, to blank. So it removed it when it translated it. So let me see if I can come up with a better example here. We'll skip through this one because this is one where it got it again. Oh, and it did even worse than the one that was further away. You could see it didn't get very many characters right at all. You just got the P and the I. Well, not even the I. Let's see. Let me see if I can find a good one here. So I went through several images where it couldn't find anything at all. So now this one was a real challenge because when it did the edge detection, you could see that part of the plate, the plate cover from the top, really did a number on the contour. And I don't think it actually identified this one as a plate. No, it didn't. That confused it too much. So let me move to the next one. There.
Black car and a black
See,
license plate.
it managed to get that one, but you can see once again, it's rotated. That doesn't look quite as rotated. I think this one actually came out better in the end. Yeah, there's almost no rotation at all.
Could you do better if your images were, you know, like zoomed in on the back of the vehicle, or not, you know,
Well,
with the image
the
not so
problem
far
with zoom
away? So
is-
you get,
Well, here's the thing: is on the Raspberry Pi Zero W, which is what the street camera is running, it can only get a frame rate of about 2 per second accurately.
Mhm. Wow.
So you have to have, in order to not miss most of the plates on the cars passing by, you don't want it zoomed
Oh,
because you'll miss a lot of the plates on passing cars. Let me see if I can find one where it was bringing in lowercase characters.
well,
Maybe starting with like a 5 megapixel camera.
I'm sorry, what?
Are you starting with like a 5 megapixel camera?
I've got a 12 megapixel camera on this.
Well, yeah.
Hmm.
So you got a lot of pixels for digital zoom, but
Oh yeah, there it is. You can see the raw data. It's throwing in a bunch of lowercase e and s's and y's. And so in my map, I say, well, a lowercase s is probably a 5.
boy.
It could be an uppercase s for all I know, but I got to choose something. And then the lowercase y is probably, you know, an uppercase y. But this is what Tesseract thinks it's seeing. And I'm translating some of the characters based on the common errors that it has in decoding the text. So, and I'm also showing the width and height of the number of pixels and the width and height of the image of the plate. So you can see that one was 42 pixels wide and 23 pixels high. So even though it's a 12 megapixel camera, still that plate is a pretty good distance away, and so I'm not getting a whole lot of pixels in the final plate image. Let's see if I can find another good one. There's one, but it's not gonna nail this one at all because it's just too far away. You can see that one's very blurred, and it pretty much didn't get anything. And that image was only 37 pixels wide and 20 high. So yeah, there's limits to what I can do
could you
here. But to
trigger
be
it so
fair,
you get more of an image of the plate?
to be fair, OpenALPR couldn't get anywhere near that at that distance. OpenALPR, for cars on the far side of the street approaching, it gets almost none of them.
Hmm.
So that's what I was saying. With
I know.
OpenCV, I can actually beat OpenALPR at detecting probable plates, but I've been unable to beat it at character recognition.
Hey,
I'm not
John,
certain what he used, but Pi image search had, optical character recognition for license plates. He had some examples for that. Did he
Yeah,
use the algorithm that you're using?
Yeah, as a matter of fact, I've been borrowing a lot from. I've been getting. I haven't bought their package, but they do. If you get on their email list, you do occasionally get their free tutorials.
Yep.
And I have looked at the one for the ALPR that they do, but I'm trying to remember why it wasn't suitable for my particular application. There was some reason I couldn't use it, and I actually sent him a message, suggesting that he enhance his tutorial a little bit, but I never got an answer back. I'm not one of his paying customers. So now here's an example of a nearby plate that should show up, fairly well. But once again, you can see that slight rotation. But that's got a nice, even with that shadow in there.
Shadow.
It still picked up the plate and got some of the characters right. It does better with numbers for some reason. It got the 748 correct, and but the NVT came out as WTB.
Hey, John.
Yeah.
One idea that might you have the picture of the license plates. Can you go to that? I think you've been showing the license plate numbers. This would be a good one, but do you show it where it just shows the license plate number?
Hang on, I've got them tucked away here. Are you talking about?
I guess that's why they still have the little.
Yeah. Okay. All right. If you took something like this, okay, and did a binary on it, where it's a 1 or a 0, would that
a threshold?
Would that give you a number that might be a threshold? Thank you, Ray. That might make it a little easier to interpret. Do you have, for example, if you took this image, do you have let's see, can you do thresholds in I always do it in Photoshop, so I don't know.
Let me.
Do you have Photoshop by any chance?
Yeah, there's plenty of
no, this is on a Pi that I'm doing this.
No, but I mean, but on your main computer.
No, I don't.
Oh, you're running on a Pi. I see, you're on a Pi. Okay.
Yeah, I mean, actually, the street camera is on a Pi 0W. The server that I'm running the code on is the Raspberry Pi 4.
Okay, gotcha.
All right, so this is some.
I mean, you can do.
Do you have GIMP?
No, I don't have GIMP. I haven't downloaded that. I understand it's kind of hard to learn, but
but for just.
If you know Photoshop,
well, I don't know Photoshop either. So.
Yeah.
Well, there's probably
just
some
saying
of us that can give you a quick tutorial in GIMP if you needed, but
yeah,
because it's one of those where you get past the first few steps, and then after that you can figure the rest out later as you need it.
Yeah. See, here's what I'm doing is I'll set the first thing I'll do is I'll turn it to grayscale. Then I'll do an auto brightness contrast enhancement on it, and then using the Pi image search techniques to find contours. You do a Gaussian blur on it, and then you run an edge detection on it, on the blurred grayscale image.
We're talking about that little 32-bit image you just showed.
No, this is to find contours, right?
No, I'm saying, the real thing is, you're getting very easy for humans to read license plates, and but your program's not interpreting them very well. And what I'm saying is,
the only thing I do on the plate image that I've extracted is I do a sharpen function.
Okay, well,
Do a
can you
5
do
by
a,
5 Gaussian blur, and then you do this add weighted function that will sharpen the image. But you're saying
I'm
that
not sure. There's another function you could put in there that might be useful. I'm not saying you would, but, and it's what is it again, Ray? Threshold? Yeah, where it's, you turn it into basically either a 0 or a 1. And it's, so like you got grayscale, there's another name for it. I want to say it's binary, but I'm not sure if that's correct.
No, I understand. I know what you're
So-
saying. The question, and I thought about that before, but the question is, what do you use as the threshold before calling it a 0 or 1? If you get a lot of variation from plate to plate, I could experiment.
Well, you would
with
start with 0.5. You
Okay.
know?
Just
And then-
split it down the middle.
Right, yeah. That one image that you have that has the shadow on it,
Uh-huh.
that would be a really good one. And then you could also say that if it has a black that's touching on the edges, if it has a black that's touching on the edge, like there, the bottom edge,
Mhm.
okay, you could just say eliminate that.
Well, actually, believe it or not, I already do. I didn't show that, but I do
Okay.
mask. I do mask the top portion of the plate because
Yeah.
that's where Texas is, and it usually has some overlap.
Yeah, yeah.
And then I mask a portion of the bottom, but you can see on this one, it doesn't always mask it out due to the precision of identifying the contours.
But like I say, I think if you went to binary here, if nothing else, it would help you be able to create specific letter boundaries. Okay.
Yeah.
And then your problem would be trying to read just a single letter.
Uh-huh.
You see what I'm saying?
Right.
So like it would cut this into eight pieces basically. And you would eliminate the one that's in position 4. So, and you also, I know there's custom plates, but generally the first 3 are going to be a letter, and the last 4 are going to be numbers.
Well, and once again, whether or not you can do that largely depends on how accurately you can hit the contours.
Okay,
Right.
let me try something here.
Right.
Leave that
Sometimes
leave that picture right there. Don't do anything. And what I'm going to do, don't move it.
Oh, I'm
Let's
sorry.
see here.
I thought you just meant
Okay.
don't put it behind anything.
Okay, so here's what I'm doing here. I'm just screen capturing your little picture. Okay. And okay, and I'm going to try to open that up in Photoshop and see if I can do something with it. I'll get out of the way here. I don't want to miss Jack's thing though, so
Okay.
I may come back, John.
All right. So you want to stop sharing, and I'll turn it over to somebody else.
Don't want the coffee to get cold.
Yeah.
Okay, I'm almost stopped.
I think we had Michael in line way back, and then Jack, and then David had something non-robot related.
Okay, you ready for me?
Michael, what you got?
Can you hear me?
Yep.
Here you good.
Okay, good. Well, I was got some questions about Roborama. I won't make it this year. I mean, I'm gonna show up and watch the competition, but what, as far as microcontrollers and maybe sensors, what do you use for those 3 competitions? Or do you need like a Raspberry Pi, or would just an Arduino work with those competitions? How do you get started? What sensors are y'all using with those? That's kind of the question. What would a guy need to kind of get his,
Michael, I can make a stab at that. To answer your first question is yes. All those things can
all
be
of
used.
those?
I would recommend those starting simpler, and there's really 3 tasks that you have to be able to do. One of them is you need to be able to navigate toward a GPS coordinate. So you have to have a GPS and some way to read it, and you have to know what your desired waypoint is and whether you're pointing left or right of that waypoint to steer toward the waypoint. The second one is you need to be able to slow down and stop when you reach the cone, and that means you have to have some way to recognize the cone. Most people are using a camera and some form of blob detection. There's some cheap cameras that have that function built in. What we're talking about this year is, we've got a bunch of people have these OAK-D lights, and we're talking about training them up to recognize more specifically a cone rather than just an orange thing. But I would say that's later on down the road. So you need some way to recognize an orange blob, and you need some way to navigate toward GPS coordinates. And then I guess the last, I'm sorry, go ahead.
So you're talking about Roborama or the outside one?
I'm sorry, I was talking about Robo Columbus.
That's what I thought you were talking about. Yeah, that I might be able to make that one this year. So that's actually some good info.
Well, I think of that as the hardest contest. So all those other indoor contests are much simpler, but still probably can all be done with an Arduino. And I would hesitate going to something more complex until you have that level under your belt.
Well, what sensors are used in those
Hey, Michael,
competitions?
let me give you a stab. All right.
All right.
In the 4 squares, all you need is encoders. Okay. And I think most of the crew have also gone to using gyro instead of using the encoder. But I can tell you that many years ago, just using encoders would be all you need. Now the next one up.
I would modify that only slightly, Doug, to say there's actually a simpler way if you don't have any encoders, which is to do it with timing. Drive in a straight line for a certain period of time, rotate for a certain period of time, drive in a straight line for a certain period of time. And you can adjust that and get it to work pretty well.
Pretty well, but with encoder, if somebody were saying you're going to approach this, how would you do it? I would say use encoders. All right, now the next one up is 6 cans. So you're in an arena and you're trying to locate a can and you're trying to push it out. All you absolutely need is probably a ultrasonic and some sort of side sensor. David's run it on his, I think on his with just ultrasonic. I don't know, you might have had your IR sensors turned on. And because it builds on the other one. Otherwise, you pretty much have to have odometry, okay? So the first one is odometry, the second one is odometry, and some kind of sensor that you can, when you drive by a can or you see a can in front of you, that you have an idea that it's a can. Usually, if you go look in some of the earlier videos that are on the club's YouTube. God, what is the gentleman's name? The guy that does the Roombas. Ray, you know him.
Paul.
Oh,
Jim?
yeah,
Okay, well, anyway, and there's also a really good example of it. You can watch a guy
James
who did a tape. Huh?
James.
Yes, James. And the other one was that if you look at, there was a guy that visited us from Vancouver, Canada, who came down to run our tabletop. And he had a little robot about this big, and we have the video up there. And he used nothing but a couple of IR sensors. And he used some to tell him when he was at the edge of the table. All right. And because he did have odometry. but he would drive down the table, and when he saw a sudden jump in the distance he was reading, he knew he went by a can. Okay. And so he would come back, turn, pick the can up, go, and then go where he wanted to go with it. So you don't need a camera to do it. Okay. If you want to try it, how most of us are doing it, probably the easiest way is a Pixie cam. All right. But you don't need that. I mean, if you just want to get going, hey, Jack, what are you using in yours? On your 6 cam?
I'm using a Husky lens.
Okay,
That
that's even
works,
cheaper.
Yeah, and it works about the same as a Pixie cam in terms of programming and everything.
Yeah. So Husky lens or a Pixie cam would probably be the next step up. And then if you really wanted to go to, you could go with a Oak D LiDAR, which is $150, but you don't have to go that high, you know. And so, but I'm just saying this. So those were now the sample and retrieve. Now, here you got to pick out the objects, and the objects are a block, a ball, something, a Coke can, not a Coke, yeah, a Coke can, a Diet Coke can. So it's a silver can with a little red writing on it, and a few other things. So we haven't had anybody successfully do it. So the assumed way we think people are going to do it is geometry to get to their home base and back, right? And some sort of camera sensor that allows them to run a small AI model to pick out the objects. Is that the only way to do it? I don't know. Nobody's done it. So we'll find out when Kareem, I think that's the approach he's going to take. And I think it's a valid one. We'll see how it goes.
I would
But
add to
if
that.
you, yeah, go ahead.
Add to that, as you could probably tell from what Doug was describing, there's lots of different ways to solve these problems. So there's not necessarily one optimal way. And I would just offer, if I can present for a minute, here is a can competition collecting the cans that uses no sensors at all other than wall following. Let's see, allow. Where'd it go? Do you have a video in front of you?
Yep.
Okay.
Yeah. Yeah.
This is my Lego robot collecting the cans. This is not as simple as it looks because accurately following the wall without losing cans turned out to be a hard problem.
Somehow I'm imagining that this was the catalyst for some rules changes.
Actually, this was something like this was run later than this, where they had two arms that stood up like goalposts, and then when they started, they dropped down, and they swept.
There's
Is
sticky
there
tape
on there?
Sticky
Oh, I
tape.
thought, yeah.
Also, this is the older can collecting course that had that was a T shape, which I think is actually a superior shape because it's harder to navigate.
So you can see there's a lot of clever ways of doing things.
Well, that was the point I was trying to make. There's not one right way to do this. So be creative.
And I would say that definitely look up the tabletop competition from that guy from Vancouver. I'll actually see if I can find it, and I'll see if I can find it and put it on the post here. But I mean, that was a good example. Usually when they do,
well, I think this is a good example, Doug.
well, yeah. No, I mean, it is. It is a good example, except that now you have to only handle one can at a time. So, that.
Rule makers hate innovation. Just remember that, Michael.
No.
Michael, here's one thought. You could start with whatever it is that you got working that powers that claw machine.
Yes.
Just add wheels. Just add wheels. And
You know,
colors.
I was telling my wife that today, that if I get a gold star, I have to put wheels on my claw machine. So
That's it. Just add wheels. You're most of the way there, really.
I still think it looks like you're going to float yours around in weightlessness.
I know I got to keep strapped in here. So
Next time we're going to come in board, he's going to have NASA written along the back top there. It's going to be pretty awesome.
just call me Major Tom.
Major Tom.
That's an old song from
Ground control.
Yeah, ground control. Right.
Space Oddity.
Oh, anyway, well, thank you very much. So I might be able to make that GPS thing, but
that would be David Bowie, the artist on that song there.
yeah, thank you. I forgot his name.
Well,
I'm getting, senior moment there.
Michael, I bet he'd be the same age you are if he was still alive.
If he's still alive, yeah. Yeah, but I'll be there this when we have the competition. I won't be doing anything, but I'll be observing because I want to. I've done that. I showed y'all that line. I've done some line following, and I've made a wall following robot. I never brought it up to the club. I just let it go around in my kitchen. I still got it. I've probably got about 5 robots I've built.
Bring them.
Remember the club robot we got years ago and put it together, and I still have that. I might try to start using that again.
There you go.
Well, Michael, I think the idea was that was supposed to be kind of a general purpose robot, and then whatever competition you want to enter, you could add whatever sensors or gripper was needed.
If you got
I took the claw off that robot and put it on my claw machine. So
but you don't need the claw for Foursquare. You just take the club robot parts that are left and use it for Foursquare. You're there.
There you go. It's too close to start doing all that now, though. What is it? 2 weeks from now, right?
18th, 2 weeks, 4 days.
18th. Yeah, 2 weeks, 4 days. Well, thanks a lot, because I want to be ready for next year. So,
cool.
I'll start
Hey,
messing with that.
John.
Ted was telling
I
us
think
about
when
Jesse building entire robots and writing all their software in 2 weeks.
I want to know what 7 Photons is doing back there. What's the cup robot?
I think Jack's up next,
So-
and then we got David.
Yeah. All right. So I was glad a few days ago I was able to get it to finally make a full theoretical cup of coffee, but that only happened once. So now I'm trying to fix my initial cup dispenser thing. I would originally have it where it would grab it by the right underneath the lip. But the problem that I've been having with that is sometimes it just sticks too much to the other cups. So it's been very unreliable, and sometimes it will slip, or sometimes it just won't be able to pull the cup off at all. So I'm trying to come up with a system to where it grabs it right on the lips so that there's a little ridge on it. And then that way it doesn't slip at all, and it can just pull it right off. And I think I've got it working now. I'll do a demo of that real quick. All right. Second. Not sure if you guys can see.
Yeah.
And then there it goes. Exactly 1 cup. I've been trying different weights too. So I'll add on a full stack of these smaller cups. And that seems to be able to handle that. However, I doubt that I'll ever have that many cups on there.
A lot of coffee.
Yeah. Ah. No. Okay, well, apparently more work needs to be done, but I'm not sure. I think there might be some
I
problem with
recommend
the...
Folgers crystals. That's
I'm-
coffee around.
I'm sorry, I couldn't hear
Instant
that.
coffee. Oh, I said Folgers crystals. That's what I recommend.
Ah,
It makes the
yes.
best cup of coffee, you know. Freeze
Yeah.
dried.
All right. Well, I think we just saw a demo of a live demo of a working robot.
We did. That would be a gold
Oh,
star.
all right. All right.
More gold stars.
Ah.
So, Jack, are you trying to just grab right at the lip and then pull down?
Yes. Yeah.
And
Mhm.
so, is that guaranteed not to grab 2 lips?
Yes. Yeah. Yeah, it's like just a few millimeters of a ridge, so it will only grab 1 lip.
I have to tell you, when I pull paper cups out of those things, I frequently get more than 1,
Oh, yeah.
even with
Yeah,
my
that's
human
true.
hand.
Yeah. Yeah, I was originally using a little mechanical dispenser, or I mean, yeah, and I had to change it to a solenoid because that was really unreliable before.
Well, great progress.
Oh, thank you.
There's
We
a
probably-
classic video of, you know, the automated coffee machine where you make your selection, the coffee pours out and it just, goes like right to the drain of the machine, and then
Then the-
afterwards the cup
Yes.
falls down, so.
Oh, dear.
Well, I fully expect
Yes.
that someday we're going to all meet up at the makerspace and you're going to make us all a cup of coffee.
All right, sounds good.
Yep.
Yeah, it's gonna be a little difficult to lug down there, but give it a
Well,
try.
one of the really good points I thought you made about your presentation for the soft drink distributing robot was the hang-ups caused by little things. Not big overall design concepts that are wrong, but just getting this one little piece to work that turns out to be a huge hassle, and which probably ultimately is the whole challenge of engineering, really.
So like Jack, so how do you do the cup thing? Do you have some little ridge that's just ridge shaped to grab it? Do you have some kind of like friction plate to hold the other ones?
Yeah, I'll see if I have another. You know what? I think I threw away my other prototype. But oh, here we go. All right. So
I wonder if you could do it with like cogs that, or like something that grip individual cups, and when the teeth go by the ridge of the bottom one, it just falls down.
Well, let's see what it's got.
All right. So this is the gripper. I'm not sure if you can see. There's a little tiny ridge there, and that's what I've got for the for this one. But the problem I'm having is for the that's what I did initially, and I was concerned because the cap machine or the cap dispenser, I've got it where it drops a single cap on, and but when it would go to release it at the cap press, it would fall off at a bad angle. So I was wanting it to where the cap would drop right onto the cup's lip without any gripper interference. But what I'm thinking I'm going to do is I'm going to have it to where it brings it over to the cap press, and before the gripper releases the cup, I'm going to have the cap press come down and kind of hold the lid in place as the gripper opens. Hopefully that should work.
What's holding the other cups from coming down?
Just this little solenoid. I'm not sure if you can see it right there.
Yeah, a little bit.
Yeah. Just a single solenoid, and then in order to keep it from falling out, that's what these things are for. I mean, from tilting off of the solenoid.
All right.
Mm-hmm.
Oh, the solenoid it's just friction. It's just pressure.
Yes. Yeah.
That's all it's doing. Oh, okay.
Yeah.
Okay.
Mm-hmm.
Cool.
Yeah, that'd be
Oh,
fun to
thank
see
you.
in action in person.
Yes.
Well, cool. Thank you, sir. And I
John,
think-
I think when Google stops us from getting those images where there's like characters that are all skewed and lines are going through it or they're not clearly written, that someone will come up with the solution for optical character recognition. We won't have to do that anymore for it. So, and same thing with all the pictures with the bus in it or the airplane in it, same sort of thing. I think we're just doing that for Google. We're the humans.
We're labeling data for their data sets. So we are.
That's right.
We are free slave labor for their
Still.
machine learning models.
Yep.
Yeah. And they're
So when those
providing you
disappear,
the
you'll know
app.
someone's created the ultimate model.
Yeah. I think Mr. David, you had something in queue.
Well, yes. Let me set the stage. I was watching some videos of robot arms catching balls thrown to them, and you guys may know in the minor leagues they've now they're going to use Hawkeye in the coming season. The umpire will still be there, but he's got an earphone that's the electronic device is calling the balls and strikes. And in order to do that, they've set up, I don't know if it's hundreds, but dozens of cameras all around and generate the 3D trajectory of the ball. And the little video I had watched was a robot arm catching a ball that was thrown to it. It was doing a similar thing, but it only used 2 cameras. But it was in a highly controlled environment. That is, they were inside a room that had all dark walls and bright white lights and, a very controlled environment. And then I was looking at the gripper. Excuse me?
I said no wind,
No, yeah, exactly.
Perfectly
Very, very
controlled.
accurate. And of course, no curveballs or anything, you're just tossing the ball. And I was looking at the gripper that the robot was using to catch the ball. And it makes perfect sense because that's how we catch the ball. We even make our hand bigger, with a glove to catch the ball. But then I started wondering, if you had a computer and you really are calculating the trajectory of the ball, could you just catch the ball with a flat plate? Do you actually need to be able to grab it? After all, I mean, we can balance and so forth, right? So then I came across these 2 videos, which I would like to share here.
Sounds like the ball would bounce off the flat plate.
Yes, it does seem like, unless you had it perfectly timed, right? So here's one perfectly
Right.
timed. Can you guys see this?
Yes.
That's Carlos Alcaraz
Yep.
at Wimbledon.
Yes.
Now watch this. You see that?
No.
You did not see it.
What did we miss?
Yeah, he caught the ball with his racket, basically.
Caught the ball with his racket with a flat plate, just by timing it.
Oh.
Okay.
Oh.
I got a
That's
better one.
Pretty complex
Of Roger.
movement, though. I mean,
Yes, it is. Here's Roger Federer doing the same thing, and they show it in slow motion so you can kind of see it. Now, if Roger Federer can do that, he doesn't have a glove. And not only that, but if you look, he's not even looking.
Right.
You know,
And the racket normally would make the ball very, very bouncy, right?
right. And if you look, you can,
My guess, the calculations that he's doing in his head is all muscle memory, and he had to do that way more times than we might want to guess to figure that out.
I'm just showing you this to show you that it is actually possible for somebody who's calculating that to actually catch with a flat plate, no glove needed. And if you look at the ball in slow motion, let's do it again. You can see it's still spinning when he catches it. See that? The ball is still spinning. Okay, so I think that's a challenge for our robot builders. Oops.
Oh boy.
That you can actually catch a ball coming at high speed on a flat plate if you time the movement of that plate correctly. To decelerate.
That was kind of a lob. It definitely wasn't a super fast ball.
All right. Do I need to go back and show the one of Alcaraz again? Would you like to see that one again? Because it is a super.
Oh, is that more of a straight line shot?
Yeah. Just look it up. Say, Alcaraz catches ball on racket.
Okay. Of course, there is a little bit of a rim that the edge of the racket makes. I mean,
yeah, but if you look at Federer's catch, it doesn't go anywhere near that rim.
Oh no.
No.
Oh, I thought it ended up on the ring.
Well, when he slipped it back into his other hand, he rolled down to the rim. But during the catch, it doesn't.
I would suspect that if you ever got to the rim during trying that, it was gone. It'd have to be in the center.
Well, hunting around, I found Carlos Alcaraz doing that, and Roger Federer, and there's also a real good image of Rafa Nadal doing the same thing during the game. It's so practiced, and they hardly look at it that I assume they must do that all the time, and I've just never seen it before. But it does suggest that it's possible. As I say, it's not just properly decelerating, but it's also having the racket or the flat plate normal to the ball, right?
Yep, so it follows the curve and all that sort of other thing going on, and yeah,
exactly. But still, it's doable. It's doable.
Okay, so I just put a link in. Quick search. Here's a robot that would balance 5 balls or juggle 5 balls between 2 arms. So, yeah.
Well, would you like me to put those others in as well, Carl?
Yeah, please do. Might as well. I mean, it's good inspiration. It's a little bit of a challenge for us, but.
Michael, is that the happy little cloud guy on your shirt there, on your image?
I suck at darts, but I'm good at it. What's that?
Is that the happy little cloud guy on your t-shirt there, on your image?
What? That's a guitar.
Oh, no,
Arlington
not this
guitar.
image. The image that comes up when you're, yeah. I forgot what the guy's name is.
Hey, Michael, you liking that man cave?
Oh, I love it. I've got my AC unit. I'll show you. I haven't got it installed, but I will work on it today. See that piece of plywood?
Yeah.
That's where the air conditioner's going to go. It's right above me. See, it's metal, but I'll replace it with some plywood. I'm going to cut a pocket in there, and I'm going to have my air conditioning, and I'm loving it. And it's cheap. The thing about it is, I probably got all it. I know for the shed run me about $750, and then probably with the insulation and stuff, probably no more than 25. I mean, probably $1,200 maybe so far. So it didn't cost me nothing.
So you don't have it really wired into the house. You just have you plug in an extension, or what? Or do you actually have it wired?
I ran from my pole out here.
Okay.
I'm running from a breaker box. I've got power running in here, wall sockets and everything. Yeah.
His next trick.
483.
Huh? My breaker, I got a
490
breaker
volt three-phase?
Not yet, but I'm working on it. I'm coming from an
Lord, power,
industrial world. I've worked with three-phase for many years, so I know a whole lot about it. But, yeah. No, I got it coming from a pole on a cable. I wired it in here. So I'm good to go.
Cool.
Probably doesn't, that's code though, right? I mean, don't usually allow that, right?
Say that again. Say that again, Ray.
Stringing a wire on a, or cable in the air, that's not up to code, right? I mean, if somebody came and inspected it, they probably took it
If you have
down,
above,
right?
if you have above wire
It's
wiring, it's
it's
how they
Romex.
do it.
It's outdoor Romex. I put guy wire and then wrap the Romex around it. It's external Romex. It'll take the UV rays and all that. No, it's not code. No. So, but don't tell on me, okay?
Right. No, your secret's
It's
safe.
redneck. It's redneck. So it's better. It's one step above an extension cord. So.
Yeah, my wife had a rent house where somebody just, I don't even know if it was outdoor rated Romex, but just a cable from a breaker box in the house going out to a Dutch garage, hanging, in the air.
I've actually got it on a breaker and everything out there. So.
Ray, you don't know
breaker.
how challenging it is to understand what you're saying.
Oh, you can't hear me?
No, it's Ray. His connection. His
Oh,
connection
my voice is
halts
garbled.
like it is right now.
Again, like it was the other day.
Yeah.
Yeah, you just locked up.
Yeah.
Oh my
Hey,
God.
hey, Carl, put me in the queue. I found something, some cell talking about catching tennis balls. I found Mark Rober's automatic dartboard. I don't know if you've seen that.
Let's pull it up. I don't know if there's anyone else in queue after this. Not that I've heard. So pull it up, John. What you got? I put some links in there for some robot.
I'm gonna pull up the video. It's actually a 6-minute video. I think I'll go ahead and play it from the beginning then.
All right.
I'll go ahead and present. And let's put this at the beginning. And get the sound up.
I suck at darts, but I'm good at engineering, which means
You getting sound?
I'm actually really good at darts. Most of the projects built for my YouTube channel take a month or two to pull off, but I've been working on this piece with my former NASA coworker John for over 3 freaking years, and here she finally is. It's fairly self-explanatory, but you throw a dart, and as long as your initial throw is somewhere within this diameter or so, the dartboard helps out a little bit. And what's cool is if you use this dart, it will make you the world's best dart player because you get a bullseye nearly every time. And even if you don't, it's really close. But if you use this dart, it makes you the world's worst dart player because it calculates the initial trajectory and then moves the board in the exact opposite direction. So eventually we took this thing to a bar to see if it would work in the wild. Before we get to that, let's talk about how it actually works. Fundamentally, there are 2 main parts to the system. First, you need to somehow predict where a dart is going to land with a typical throw from regulation distance. And you have about 200 milliseconds to do that. And then second, you need to somehow move the board to that predicted location. You have about another 200 milliseconds to do that. Let's start with the first part about how we predict where the dart's going to land. So the real secret here is that our dart has these tiny retro reflectors on it, and then we have a Vicon motion capture system. As humans, we can see in 3D because we have 2 eyes, and our brain calculates the difference between the 2 images and then tells us how far or close things are. This is why if you close one eye, you instantly lose that depth perception. So that's basically what we're doing here, except we have 6 eyes all around the room. And each of these eyes, or cameras, can take a 4K resolution picture 260 times per second. But since it's hard to visually separate something so small, moving so fast in front of a busy background, they actually use IR. So they blast out IR from all these IR LEDs, and then it hits the retroreflectors and then bounces back to the lens. So when I wave the dart around like this is what you and I see, but the motion capture system just sees a solitary dart floating around. One of the reasons this board took us so long to build was that for the first 2 years, we were trying to make our own motion capture system. So we had our own cameras and one of these awesome NVIDIA TX1 boards, which is basically like a Raspberry Pi on Russian steroids. But it turns out it's a super complex problem to solve, and the Vicon system was just turnkey. So now that we have the XYZ position of the dart as it travels through the air, we use some MATLAB code to then predict where it will land. And the trick here is that anything you throw into the air, neglecting air resistance, will travel in a perfect parabola. Even something you wouldn't think of, like a high jumper, if you track their center of mass, it actually follows a perfect parabola shape. So we used our understanding of parabolas, and from a side view, we use that to predict the final up and down position of the board. And then to predict the final left-right position of the board, we know from a bottom view, a dart will follow a linear path. So we use good old y equals mx plus b, and the y-intercept, or b in this case, tells you how far to move it left and right for the final position. So now we know exactly where to move, let's talk about how we actually do it. So the board itself is on 2 linear sliders, which allows it to translate to any specific location. So that provides the track on where to move, but the engine would be these 6 stepper motors you can see from the front. Each motor has a spool and then some fishing line, and they all attach to the center of the back of the board right here. Once we have the predicted bullseye spot, the computer does the trigonometry and then sends the commands over here to the motors. So to move to the left, it would say like, you need to spin up, but you need to unspin at the same rate. Now on the back, you can see the computer signal comes into this Arduino compatible board here, and then you got some preamps here that bump up the voltage signal to the 6 individual stepper motor controllers. And these stepper motor drivers take the moving instructions and combine it with the power from the plug in the wall after it goes through this AC/DC power converter. And then finally, a bunch of voltage pulses from the motor controller cause the motor to take small steps and either wind up or wind down. Now keep in mind, all of this happens in less than half a second and allows us to hit our sub-millimeter precision in our board positioning. Oh, and we don't just make one guess on the final position of the board. We update and refine that guess anywhere from 10 to 100 times, which is why sometimes you sort of see the board jitter into the final position. So we took it to a bar to see what people thought. In general, we found if you're really drunk, you get so pumped at your new abilities, if not slightly confused. I used to suck at dark. In a way, it's a curse, but when I get an idea like this, I can't not do it, even if it takes me 3 years and is a terrible financial decision. So I want to give a huge thanks to the cool people at DollarShaveClub.com. I don't really feel that comfortable with the whole Patreon thing, so if you think this is cool and you want to see more stuff like it in the future, you should go check them out. I've been a fan of what they do from the beginning, and not only does it save you time and money, but I personally prefer their razors.
All right. We'll stop it there. The 3-year project just to have a moving automatic dartboard.
It is pretty cool. Hey, can you put the
I
link?
take that means there's still hope.
Oh, you want to put the link in? I'll put the link in the chat.
Yeah, if you could, that'd be good. Automate anything.
Mark Rober is really, he's real entertaining engineer type. Also goes after, he's the one that builds those glitter bombs for package thieves.
And for online scammers in India.
Yep. Yeah, they recently teamed up and had a project where they actually went to India to mess with the scamming call center there.
Yeah.
Set off fart bombs in their midst.
Yeah, there's videos. Yeah, there's lots of stuff. If you find Mark Rober's site, you'll get long hours of entertainment there.
Nice.
Okay, hey, John, before we leave, I want to show you the idea that I had, and it didn't work as good as I thought it would, but I thought you might like to see it.
Yeah.
Okay, so
actually, while you were doing that, I actually went off and added a line of code to binarize the image and tried several different thresholds, and it didn't work very well either. You got to hit this very specific threshold just right, and it's probably going to be different from image to image.
Well, but what you could do is you could, since you don't really care when they get, otherwise you have the capture of it, and then you have determining what the number is. You don't need to know that real time. So you can process that later. In other words, you can take those images and use them to, you could get, for example, a binary image, you could come through and you could say, okay, I'm going to take 0 to 1 in 10 steps and go boop, boop, and then read it each time and see which ones. You might pick one up at one and one at another, and you might find that you could get it that way.
Yeah,
I'm just saying there's. Yeah. I know you don't, that way you don't have to worry about it on your doing it instantaneously, because you what if it took 10 seconds?
Oh yeah. No,
you wouldn't care.
I intentionally have a 2Pi system. One is the motion detection and image capture on the Pi 0 on the camera in the street, and the other one is the Pi 4 in the house, which runs as a server and does all the hard work, all the hard crunching. So yeah, it can take its time.
Yeah, but like let me for example, let me show you this, because I can find it. Where was it? Okay, let me show this.
Yeah, I tried it out. I started at 127, the threshold of 127 out of 255, and it was terrible.
Okay, so here's what the histogram layer looks like. So you don't want to be over here, because that's not going to give you any information. You could do a histogram spread to start with, but as you slide down through here, what you might do is find, okay, I can see the piece. I bet you could pick out the PC and the 033. The N and the 4 you can't get. They never really get very distinct. But you would at least have the PC and the 033. And you might be able to train it to get that in the 4.
Yeah, but then you get into which one of them is the one that's accurate.
Well, no, the PC and the 033, I think, never really. I mean, once they until they disappear, there seems to be, and like I say, let's see, this is 137. So what you need to do is kill the tail. That's all this stuff. And then you just go to about halfway. 137 would be 100 and would be 60 something.
Yeah, no, certainly there's a lot more I could try to pin this down.
Yeah. Well, I mean, it's just my first thought was that I might have promise. It might be one of the techniques. Maybe your algorithm goes through 2 or 3 different things and looks for, okay, what's going on? Cancel. Because here's your original image right here.
Hey, you stopped sharing, Doug.
Oh, okay. That's all right. No big deal. But I'm just saying is that maybe you try different things and see if you get agreement. For example, if you have tried 2 or 3 things and they all say that the first letter is a P, it's a P,
Yeah, you can have a voting system.
I'm sure. Yeah. Anyway, kind of cool. I think your problem is very interesting. I know that sounds like one of those 3-year dart problems to me, if I ever saw one. You know, I mean, it looks like you're making a lot of progress, and you've got a clear objective on what you want to do. That's really,
Yeah,
I
well,
mean,
wanna
that's
hit the
what makes a
bullseye.
good project. Yeah. I think you're getting really, I was amazed at how well you were catching out the little rectangles. But I would
Yeah.
look at that guy's data set and see if that idea of fuzzy versus non-fuzzy, because he's somehow picking out license tags at a pretty good rate too.
Yeah.
So I don't know.
I kind of wonder if what Carl did would apply. Remember, you were trying to find like the very center of a line and use I guess it was the opposite of dilation. I forget what it's called now.
Erode and dilate. Yeah, I've
Yeah.
done that too to find contours.
Yeah, could you do that with the characters? You think that would work?
I haven't done it with the characters. Maybe I can play with that as well.
Yeah, because Carl was using that to find like the center of a line, right?
Well, I
Sort of
I was using it to
Good
when contiguous things and lines weren't they were having breaks for whatever reflection or whatever problem. But I got the impression that, John, your issue had to do more with the 4 corner points of the contour being cockeyed or something, and then
yeah,
the letters being skewed at just enough degrees the tesseract wouldn't work.
Well, that was kind of half the problem, is
Yeah.
recognizing that part of the reason I'm getting inaccurate text detection is because it is rotated. So I can either find a way to correct the text rotation or find a way to use the data that I have, like Doug was suggesting, to get better character recognition, or a combination of the two.
Yeah, but I kind of like the idea. Otherwise, if I understood what Ray was saying, he's saying that what you do is you take your image and you vectorize it into straight line segments.
yeah,
Okay, and so then now everything is really simple. You just got straight lines. You know what I mean? Now, so that might be able to allow you to pull the 4, because even though the 4 looks sort of like kind of like a sloping triangle, you'd have one line and one going this way. That'd be enough for you to be able to interpret it as a 4, maybe.
Oh, now you're really getting down the nuts and bolts of character recognition when you're doing that.
yeah.
Because normally Tesseract does that for you with the training data.
Yeah.
Huh.
Well, I mean, training works too. I mean,
Yeah, and that's why I just ordered a book on YOLO just now, a few minutes ago.
Yeah.
I went ahead and ordered, not on YOLO, but on Python and image neural networks.
Yeah.
Somebody
We
solve those
I really-
tend to think of, how much would it cost to have
Probably
a guy
image
sit
search
out
also
there
has
and
a-
write down license plate numbers on your front lawn, So it's that could be pretty expensive. So
I mean, you can only buy so much Lone Star beer to feed the guy, and that does run into money eventually. I'm just saying.
sunscreen, a decent hat,
Yeah, I
Because you
just-
know,
bug spray.
because we can't feed him good beer. We get to. I said, well, I like Lone Star actually, but we need to feed him something near water so he stays hydrated. But yet he thinks he's drinking beer. So Lone Star gets close. It's like,
well, and one of the things I just did related to this project was Richland Hills they relaunched one of their programs. It's called Captive, which is an acronym for something. Basically, it's about sharing video evidence for crimes committed in the neighborhood. They just basically get a list of people who are willing to share their Ring camera data or whatever. I sign right up. It says, hey, I got an advantage. I got a view down the street and I can give you license plates. So I just signed up for that. That was the whole idea all along. But the gravy is being able to get registered with them.
Yeah, I've thought about putting a camera, not trying to automate it, but putting a camera that sees down my alleyway, because I figure that's probably my vector of attack in my particular house, People just drive down the alleyway, they see the garage doors open, get out, and it's gone before you even know what hit you. You know, chuck
And
it
one
in
of
the back of the truck and go.
Yeah, and one of the things I'm doing right now, I got in my hand here, is to fine tune this thing. The camera I'm using has an automated IR filter where you can flip the IR filter out at night and then use my illuminator, my LED illuminator, custom job that I did. But I think one of the problems is my focus is slightly off because the focal point for IR is slightly different than that for visible light.
Yeah.
But the camera module I got doesn't have an autofocus on it. But
Mm-hmm.
what I'm doing here is, let's see if I can get that turn, is I got one of those little Pololu motors, and I designed a gear, a rack, what do they call a linear gear? What do they call those? Like rack and pinion. And I'm going
Could
to
be,
put
yeah, a rack.
also 3D printed a gear that goes around the lens on the Pi camera that fits in here.
Yep.
And so basically, I'm building my own autofocus camera out of a Pi camera. And I just now got in the PCB just today that I designed to put these optical switches on. So that little linear gear that goes out comes back. I can precisely locate where the focus points are as I turn the gear. So that's still a work in progress.
My wife and I's latest security measure, we actually got a gun rack for the back of my truck and a couple NRA stickers. And we'd figured, because we use that truck to pull our camper with. And so we figured, okay, they probably are less likely to mess with the truck and the camper. They see the NRA sticker and the gun rack in the back, even though we don't own a gun. So
Umbrellas. I always see those gun racks with umbrellas in them.
umbrellas, yeah.
I think some guy actually tried to build a like on a pan tilt. He's got a pan tilt mechanism and motion detection, and put like a hose or it might have been a paint gun or something on it. Just hose it down.
I've got these lights that are just housing lights and that kind of stuff for lamps that light up at dark and that kind of stuff. Yeah. And I've got two of them right on either side of my property. And I'm just thinking to myself, if all I did was do nothing but maybe look like it's ruggedized or something, and print up a couple of things and just do body recognition, because I've got all the power I want because it's house power, and just have the thing follow them. Not even to actually do anything or emit a laser beam or nothing. Just start following, with just every now and then blink a little red light or something. I bet that'll scare off. Use that.
Just hook a flashlight to it that the beam follows them.
Do that too. Yeah.